Yeah, so hi, good morning. So I'm videotaping the lecture. Hope that is okay for you. Great. So, today, I would like to talk about the quantity theory of money, which is the relationship between money supply, the goods and services produced, and the price level, or like the inflation rate in the end. And I would like to motivate this lecture by looking at the scale where we have a relationship between money supply on the left-hand side, the goods and services produced on the right-hand side, and with the scale, we want to measure the price level. And now it seems to be the case that the scale is balanced. So our prices are normalized to the level of 100. Now we can ask the question, what happens if money supply increases by 100%? So the central bank performs an expansionary monetary policy. And yeah, what happens then to the price level? So, like the student says, it goes up. Huh. Like there is one answer in economics which fits to each and every question. Like it depends. Like it depends on what's going on the right-hand side of the scale. So nothing happens to the price level in case that the number of goods and services also increase by 100%, because then like the scale is once more balanced. But the student derived his insight that the prices will go up, like under the assumption that only money supply increases by 100% and nothing happens to the right-hand side of the scale. So then, of course, there is an imbalance, and we will observe that the prices also increase like by 100%. Like this scale can be used in order to talk about the unintended side effect of a too loose monetary policy. So one cost can be like a higher rate of inflation. We can also use the scale like in order to derive the growth target the ECB had with respect to money supply. So from 1999 until about 2020, so for about a 20-year time period, the ECB had a growth target in place for like the monetary aggregate M3. And yeah, let's try to use the scale in order to derive this growth target. So first of all, like it is the case that we have to think about like inflation. So when we put like 100% more money supply on one hand side of the scale, the inflation rate would be like 100%. And this is too much because like the overall goal of the ECB policy is price stability. And the ECB defines price stability as like an inflation target of 2%. So we need 2% more money on the left-hand side of the scale so that the prices go up by 2%. And furthermore, like we have to think about by how much do goods and services increase over time. So we have to think about like the growth potential of the euro area. And the ECB did some estimates and they assumed, yeah, the growth potential for goods and services, this is 2%. So we also need 2% more money on one hand side of the scale so that we can finance like all the goods and services. So for like a 20 years time period, the ECB had this money growth target in place, and it was like 4.5%. 2% more money because we want to have a 2% inflation rate, 2% more money because goods and services might increase by 2%. And then there was like a small correction factor for the like velocity of money. This is like half a percentage point. Great. So this is like what I would like to talk about today, relationship between money supply, goods and services produced, and the price level, and then also like the velocity of money. Let's start. So, inflation is an overall increase in prices, not only that like single uh, goods price increases, but it's an overall increase in prices. So a broad price index increases. I'm using here the Mankiw introductory textbook to macroeconomics, chapter 5. And in this chapter, we are talking about a classical theory. So we have a focus on the long run effects of money supply on the prices. So goods prices are flexible in this chapter. In case that you want to read about a chapter where prices are sticky, you have to go to chapter 10 of the Mankiw textbook, and there prices are assumed to be sticky. In our chapter, it will be the case that in case that we want to understand inflation, like we have to understand money and we have to understand the velocity of money. And I would like to start with a um, real world example in order to highlight like this relationship, the relationship between money supply and velocity, and then the price and the number of transactions. So M, that's money supply, V, that's velocity, P are the prices, and T are the transactions. And this is my real world example. So Lolek and Bolek are on a campsite and they are making holiday on a campsite. So both walk because they don't have a car over to the next supermarket, which is like 5 kilometers away. And they buy a box of beer with T equal to 20 cans. So T is equal to 20. On their way back, Lolek becomes thirsty. And Lolek has still money supply of 4 euros in his pockets. And Lolek asks Bolek whether he can buy a beer from him. Bolek agrees and fixes the price to like 2 euros per can. Lolek drinks one beer, but auf einem Bein kannst du nicht stehen. You cannot stand on one leg. Therefore, Lolek is still thirsty and decides to buy a second beer. But after a few minutes, like Bolek, his friends become thirsty. Since now he has 4 euros in his pockets, Bolek decides to buy like 2 beers from Lolek. A few hours later, they are back on the campsite. The box of beer is empty, and Lolek and Bolek are drunk. How is that possible? Like in our economy, we only have money supply of 4 euros, and this is good to finance transactions with a value of like price times transactions. Like the price of a can of beer is 2, and there are 20 cans in this box. So with 4 euros money supply in the hands of Lolek and Bolek, they can finance transactions of 40 euros. So how is that possible? Yeah, we have to think about like how often has money changed the hands? In other words, we have to find out like how large is the velocity of money in our example. And there, this equation helps. Like we know more or less all the ingredients to find out the velocity of money. So we know money supply, we know the prices, we know the transactions. Then we can solve for the unknown variable. We can solve for V. So V is equal to the value of the transactions divided by money supply. So the value of transactions, that's equal to 40, and money supply, that's equal to 4. And hence, the velocity in our example like is equal to 10. Um, Great. Any questions? Okay. Then I would like to emphasize that this quantity equation is an identity. So it will always hold. So when one variable changes, it has to be the case that one or more than one other variable also has to change. What happens in the Lolek and Bolek example in case that money supply would increase? So I would think that in like this the real world, it would be the case that the velocity would decrease. So like this is my perception because Lolek and Bolek are friends. They would not increase the prices. They have a friendship price of €2. I think that this would stay constant. Also, like T, the number of transactions would stay constant. They will always drink all the cans of beer which are possible, which are available. So when money supply increases, I think in this example, prices would stay constant, transactions stay constant, but the velocity would decrease in this case. Until now, we have a quantity equation where we have one variable included, which is t. This is completely in line with the textbook. So t is the transactions, and this is like the transaction version of the quantity equation. And now we are jumping to a new subchapter of the Manque chapter. And we are not talking about transactions anymore. So we are leaving the microeconomic example and we are like now switching to macroeconomics because we are putting GDP, we are putting output into this equation. And then like V has the label like income velocity of money because we have included like input income or output on the right hand side of the equation. Okay, now we have to talk a little bit about real money supply, real money demand, and the relationship between like consumption and money demand. So, like in macroeconomics, we frequently talk about M over P as like the real money supply. Um, like in our example, it measures like the purchasing power of the stock of money. So in the Lolek Bolek example, like we have a money supply of 4. The prices are €2 per beer. So like the money supply which is available in our small economy is large enough in order to afford 2 beers. So the current money balance is large enough to finance 2 beers. Um, maybe I could make another example where it maybe becomes clearer what we are measuring. So let's assume that you are taking a plane to Kazakhstan airport. You have like 50,000 Kazakh dollars in your pockets. So money supply is equal to like 50,000 Kazakh dollars. And now, since you have never been in Kazakhstan, you don't know whether you are rich or no. Of course, when you have 50,000 euros or $50,000 in your pockets, yeah, you could celebrate and have a nice party. But with 50,000 Kazakh dollars, I don't know. In order to find out, you are going to a coffee shop at the Kazakh airport, and there you realize that the price of one coffee is like 25,000 Kazakh dollars. And then you know that you are not rich. Like your money holdings are large enough in order to afford like 2 cups of coffee. So you cannot celebrate, but you can invite me for a cup of coffee. That's it. But this is the meaning like of real money supply. We are measuring money in terms of good units, in terms of coffee or chocolate. Um, yeah, so we have talked about money supply. Then we assume the following money demand relationship. So money demand depends on GDP. And then we have like one coefficient there, the coefficient K. And I would like to highlight like what this coefficient K implies. Um, Also in a numerical example. So let's assume that one household has a monthly income of Y is equal to 2000, and the marginal propensity to consume is C1 is equal to 0.8. So the consumption function is given by consumption is equal to a marginal propensity to consume times GDP or income. We have assumed that the autonomous component of consumption is zero. So, like the household is spending 1,600 per month. Let's assume that the salary is paid on a weekly basis. So, therefore, like the household has to walk once a week to the ATM. 1,600, this is the consumption level per month. So, in 1 week, the household is spending like 400. So, money demand is only 400. Because he's going 4 times a month to the ATM. And then we know that there is a relationship between like money demand and the income. The relationship is money demand is equal to like K times the income level. And now we can compute like the K variable. K in our example is equal to like 0.2. And hence, there is definitely a difference, like between like the autonomous component and the marginal propensity to consume, like C1, which is in the consumption function, and this parameter K, which is in the money demand relationship. Yeah, there is definitely a difference. Um, yeah, so money demand depends heavily on the payment habits. So it depends on how the salaries are like paid out, whether it's on a weekly basis or like on a bi-monthly basis or on a monthly basis. In the UK, it has been a tradition for a very long time to pay it out on a bi-monthly basis. While, like in Germany, it was all since a very long time, at least as far as I can remember, it is on a monthly basis. So, like these payment habits, of course, affect money demand. When you are paid on a weekly basis, you have a smaller money demand. When you are paid on a monthly basis, then you will go to the ATM once. You will demand like 1,600 units. And like this kind of stuff, of course, has an impact on money demand, like how the salaries are paid. So there is definitely a relationship between consumption and money demand and the payment habits. Most important insights of this little example should be that the payment habits influence money demand. But an assumption of the classical theory is that payment habits are relatively stable in the short run, and therefore the money demand function is relatively stable. Therefore, like in a classical theory, we assume that K is relatively stable. And then in the end, also the velocity of money will be relatively stable. And this will be our next step, that we are like connecting this parameter K from the money demand function with the quantity equation. So the connection will be that the parameter K is to some extent related to the like velocity of money. So this is what I will derive in the next step. Maybe 1 minute to digest whether you have questions, yes or no. Okay, let's proceed. So, like from the okay. Now this here, the right-hand side, this is money demand. The left-hand side is real money supply. So we have a money market equilibrium condition here. Money supply is equal to money demand. We can put P on the other hand side of the equation. So we are multiplying through by P and we are dividing by K and we get to equation 12. So once more, left-hand side, that's real money supply. Yeah, right-hand side, this is real money demand. We put P on the right-hand side, K on the left-hand side, and we get to equation 12. But equation 12 looks like more or less the same as our quantity equation when we are assuming that the velocity is equal to 1 over k, then it is the case that we have made this connection between money demand and the velocity. But this also implies that when our payment habits, when money demand is stable, like the velocity should also be stable. So the velocity is influenced by money demand and the payment habits of the economy. When people want to hold only little money holdings, when K is small, it will be the case that V is large, so money changes hands frequently. And maybe you are aware of these pictures which are related to the hyperinflation in Germany. There, it was a case that like the men's were like the husbands were working in a company, in a firm producing something, and then salaries were paid on a daily basis, something like that. At 10 o'clock in the morning, salary was paid. The women, the housewives were waiting in front of the factory door. The men were like giving the salary to the wife, and the wife was running to the shop in order to buy something because the inflation rate was so high that the prices were changing within an hour, like 2 or 3 times. So the people don't want to hold money. They want to hold, I don't know, butter or potatoes or goods. They don't want to hold money. So the money holdings are relatively small and the velocity is relatively high. So the housewives are running like to the shops in order to buy something. Okay. Yeah. Equation 14, that's the quantity equation. When we write the quantity equation in percentage forms, then we have the relative change in money supply plus the relative change in velocity. It has to be equal to the relative change in the goods prices and the relative change in the output. In case that the velocity is constant, like the change in the velocity will be equal to 0. So when we are assuming that this one is constant here, then the change in velocity will be equal to 0. There is no change in the velocity. So this one will drop out in a classical theory. And now we can solve equation 17 for like the inflation rate. Huh? Huh? Which is performed on the next slide. Huh? Crazy. Uh, so this one is 0. We are solving for the inflation rate from the change in prices. So we are putting this one on the other hand side of the equation. So the change in output pops out on the other hand side of the equation with the negative sign. Solving for the inflation rate. Yeah. Inflation is equal to change in money supply minus the change in the goods prices. So the growth rate of GDP is given by the change in labor force and change in capital. Let's assume that the growth rate of output is constant so that here like the change in GDP is equal to like alpha. Maybe I should go to a different slide desk here and show you something. Uh, like here, we have a graph. It is real GDP per capita in the US, a very long-term perspective, like from 1900 to the year 2020. Also, our theory here is a long-term perspective. So what you can see is, yeah, from here on, like we have a relatively steady growth trend when we are performing like a long-term perspective, and this is our alpha. Like the economy is growing by 2% per year. Okay. Uh, so when we assume that the long run growth trend of output is constant, then we can insert alpha instead of the change in output, and we arrive at equation 19. So the quantity theory of money states that the central bank, which controls money supply, has ultimate control over the rate of the inflation. If the central bank keeps the growth rate of money supply stable, inflation will be stable. And this is like also in line with our scale model and the strategy the ECB had in place, like for a time period of 20 years. The ECB assumed that alpha is equal to 2%. The central bank let increase money supply by 4%. And then we have minus 2% plus 4%. Like inflation rate should be in the end like a positive 2%. The ECB would, in case that this relationship holds, be able to meet the target. Great. This picture also stems from the Mankiw textbook. And it is the relationship between money supply and inflation in the US, also for a very long time period. On the horizontal axis, we have the growth in money supply. And on the vertical axis, we have the inflation rate. And now if we would like run a regression through like these dots, we would get like this kind of relationship. What is very important is that this regression line like should not cut the vertical axis in the positive area or like here in the positive range or at zero. Like it should be in the negative range. Like the intercept should be negative because like this is our alpha, our negative alpha, which represents like output growth. Yeah. So like in when we are running a regression, we should expect that the intercept is negative. And this is also the case in this example here. We have a very long-term relationship. Like each dot represents like the inflation rate and the growth rate of money supply in one decade. Yeah, it's the average over a 10-year period. Therefore, we don't have too many dots here. Like we only have about 20 dots because each dot is a 10-year like period. Another like empirical relationship. This is the next picture in the Mankiw chapter. Also same relationship, growth in money supply on the horizontal axis and inflation rate on the vertical axis. But now, like we have a cross section of countries. We have a lot of different countries And what do we see? Yeah, like there should be like a positive relationship. So when the growth in money supply is too large, then it will lead to inflation. Here, like we have especially like some developing countries which show a high growth rate in money supply and a high inflation rate. What about these developing countries? Are they stupid? Why are they increasing money supply so much? They know it will lead to inflation. Or are they so uneducated that they don't know this relationship? Hmm. Like we have to think about the question, why does a central bank print too much money? In order to answer that question, we have to think about how can a government finance its government spending. One is taxes. Another one is that the central bank, that the government can borrow by issuing bonds. And the last one is like printing money, or like the government is printing bonds and then is forcing the central banker like to buy the bonds. This is like for a very long time period, this was going on in Turkey. Like here, the government were printing bonds, printing bonds, printing bonds. They were walking over to the Turkish central bank and they said, "Do you want to buy?" And when the central banker says, "No, I don't buy," then the central banker would be released. So he's losing or she's losing the job. And on the next day, there will be a new central banker. And then the government will once more ask, "Do you want to buy?" And the central banker will say yes. And then the central banker is printing money, handing over the money to the government. So it's not the case that as a central bank is stupid. And to some extent, it's also not the case that the government is stupid. But when you don't have an efficient tax system in place, and when your standing is so low that you cannot borrow by issuing bonds, then this is the only alternative to finance government spending, to have some like teachers in place to educate the kids and some policemen, and we also need like some weapons for our soldiers, always very important. So therefore, in these developing countries, which have not an efficient tax system in place and which have not the standing so that they are able to borrow, like they only have one as a last alternative, and this is like printing bonds and then printing money, and therefore, like the inflation rate is so high. Great. Assignment question. Okay. So like this figure, which you also have seen like in my lecture slides, shows the relationship between money supply growth and the inflation rate in the US over a very long time period. Each data point represents the average annual inflation rate and the corresponding growth rate of money supply within each decade. This type of regression analysis can be classified as a time series analysis because we have data from one country over time. In a first step, you should calculate the geometric average annual inflation rate for each decade. For example, the inflation rate for the first decade can be calculated as follows. So I'll write it down. Y9 in the 80s, 70s, that's equal to the price level in the end of the decade divided by the price level in the beginning of the decade. And then we take it to the power of 1 over 10 and subtract 1. Then we have the inflation rate. Afterwards, like same procedure for the geometric average annual growth rate of money supply for each decade. Then you should replicate figure 1. You should create a scatter plot and you should include like this regression equation. Vertical axis, inflation rate, horizontal axis, money supply. Fast layout number 9 in Excel always helps. And then, like, you should think about what value does the constant alpha take? What about beta? Is there a positive relationship? Is it also a one-on-one relationship? So you have to do like a regression analysis so that you have t-stats or confidence intervals. And in the end, you have to answer the question, why is the number of observations so small? How could you solve this problem, like consider two different alternatives, how to increase like the data, number of data points. You have like 10 minutes to do that. In case if you're stuck, raise your hand. This assignment together. So I'll also videotape this kind of stuff. View, let's make it 200 and augment it a little bit. So, like we said in the first step, we have to compute the average growth rate by using the geometric average over a 10-year time period. And this is in brackets, like money supply in 1879 divided by money supply in 1869 in brackets, and then to the power of 1 over 10, and then we subtract 1. So like in brackets, C7 over C6 to the power of, in brackets, like 1 over 10 or 0.1, and then we subtract the 1. Now we have our money growth rate here. 2.6% per year over like a 10-year period. There is a big white cross. When you go to the right lower part, the big white cross becomes a small black cross. Double click on that one, and you copy all the information down. And then you can also copy it to the right. Because then, like we directly have also the inflation rate. So the formula for the inflation rate is like D7 over D6 in brackets to the power of 1 over 10 minus 1. Great. In case that one of my Excel files say do not delete, it means like do not delete, do not delete, do not delete, do not delete. Great. Let's do the scatter diagram. So we are including all the information for our data set. So no labels, only the pure data. Then we go to like insert, and we are inserting this scatter XY diagram, XY diagram, point XY diagram. And there we are always taking the first one. So the first scatter diagram. And now I have to change the view to 100% again. And now this looks already like the Menke graph. So this seems to be 2.6 minus 3.3. 2.6 minus 3.3, that's the first observation, 1870. So it's this observation here in the Menke graph. So everything is fine, I would say, with respect to ordering the data. Now we can like press on one cell in Excel, then we make a double click on the graph, and there should be a quick layout button, and we take quick layout number 9, third row, third column, layout number 9, so that we get like the regression equation. Can make this like a little bit larger so that we can read it. We delete this one here. And axis title on the horizontal axis, growth, money, supply. And then we have here like inflation rate. Are you with me? Do you need more time? Were you able to replicate same results? Huh? It's a graph. Okay. Then let's do the regression, run the regression. And here it makes sense to include like the label, to include the information in row number 5. So data, data analysis toolpack. In the lower part, there is regression. So data, data analysis, regression. You have it or no? Here. What's his name again? Leonardo, genau. Okay. He has to add. So, like in case that you have to add, you have to go to File or erstmal den hier raus. File, Options. Then you have to go to Add-ins. Then you have yeah, I think this analyzes toolbox. You have to click on that one and then say OK. And then it should be there under data and then data analysis. Great. When you click on data, data analysis, in the lower part, you find one item called regression. Let's click on regression. Great. Input X range, input Y range. This is like the inflation rate. And I take all the data from G5 to G15. I'm including row number 5. Input X range. X is the explanatory variable money growth. Also, I include like row number 5, so from F5 to F15. I make a check at labels because I included the labels. And now I press OK. And I get this kind of information here. Now I start to format it. I'm deleting some stuff I don't want to talk about. And I'm highlighting some stuff I would like to talk about. So like the picture and the regression line we receive on the picture like should have the same information as here, the R squared. And also like this yellow information here should be like 100% identical. Like, the yellow stuff in the regression output should be 100% identical to the picture. In case that it's not 100% identical, you made a mistake somewhere. So first, we can check whether this intercept is indeed negative. And this seems to be the case. Like the lower and the upper bound of a 95% confidence interval is negative. Also, when we look at the t-stat, it is the case that, or like, let's write down the hypothesis. H0 is alpha is equal to 0. We always test. I always want to perform like a two-sided test. And the alternative hypothesis is that alpha is unequal to 0. The critical t-value is equal to like plus minus 2. So the idea when we perform a hypothesis test is do not reject H0 in case that we are in this area. And here and there, it is the case that we say, do you have to reject H0. So when we are here or there, then we have to reject. So now we can check this t-value. It is minus 2.5. So we are located here, minus 2.5. So the conclusion is we have to reject the null hypothesis that alpha is equal to 0. So alpha is not 0. Alpha is significantly different from 0. And that's important because we said alpha has to be 8. Then we could check whether this coefficient here is significantly different from 0. Also, here we can have a look at the lower bound. It is positive. Upper bound is at 1.2. So here we already know that this coefficient is significantly different from 0. This is confirmed by the t-statistics of 3.9. So 3.9 is located here, 3.9. So when it comes to the slope, we also can, we can formulate our hypothesis as follows, like beta is equal to 0, and alternative hypothesis, beta is unequal to 0. And because of the fact that here we have an estimated t-value of 3.9, like we have to reject this one, and hence we can conclude that there is a positive relationship between money supply and inflation. This is like one idea with respect to beta. Like we can also, if we want to, like say, we want to know whether there's a one-to-one relationship between money growth and the inflation rate. Like this is also something which stems from the quantity theory of money. So when there is 100% growth rate of money supply, inflation rate should be 100%. So there should be a one-to-one relationship. So null hypothesis, we could also be interested in asking the question beta equal to 1. And alternative hypothesis, beta is unequal to 1. And here, it is the case that we observe in the confidence interval that the 1 is included. So beta is equal to 1. Beta is not significantly different from 1. We can also confirm this by computing a t-test. When I'm in the red scenario here, this t-value is not valid, but we have to adjust. So the t-value is calculated as follows. Estimated coefficient of of 0.7. I'll write it down. So it's estimated coefficient minus plain value like divided by the standard error. The estimated coefficient is like 0.789 minus 1 divided by the standard error of 0.2. Estimated coefficient, standard error. Let's type in brackets, like estimated coefficient minus 1 divided by the standard error. Then we have our t-statistic in the red scenario, which is like equal to red t-value is 105 and negative. So the 105 like is located here, minus 105. So in the red scenario, the conclusion is do not reject the null hypothesis. So beta is equal to 1 in this scenario. 2-3 minutes to digest, and then we check whether you have questions. Okay, so let's sum up. We started with this picture here from our lecture, and we know the intercept should not be 0, like it should be in the negative range. This is completely in line with our theory. And then we should like, have a positive or like a 101 relationship between money growth rate and the inflation rate. So we are replicating this figure, which is like the geometrical average over a decade. So we have to use this like a little bit more complicated formula in order to compute the geometric average. But it's also like when we are using Excel, like it's one command and then we can copy paste this kind of stuff. Same for the growth rate of money supply. Then we are running this regression. Left-hand side is the inflation rate. Right-hand side is the growth rate of money supply. Alpha, this is the intersection of the regression line with the vertical axis. And beta, this is the slope of the regression line. We are always using in Excel like fast layout number 9 in order to create the scatter diagram with the regression equation and the regression line. In order to find out whether there is a 101 relationship or whether this kind of stuff is significant or not, the picture doesn't help. It gives you a first impression, but in the end, we need our t-statistics or we need standard errors and the confidence interval. So we need the whole regression output. Therefore, like we had to install this tool in order to get this kind of stuff. And then we are able to interpret the relationship. So last question, why is the number of observations so small and how can we solve this problem? Consider 2 different alternatives. Answer in two bullet points, two sentences. Or what is your best idea? Yeah. Okay. That's a good idea. Yeah, the number of observation is so small because we are using decades. And we cannot go into the future, but maybe we could go more into the past so that we have much older like data. Yes, that's possible. Or instead of running this regression with decades, we could do it on a yearly basis. Then we have like 100 observations or so. Then we have a lot of observations. And the other idea, what else can we do? Monthly, okay. Yeah, we could do monthly, but then we are leaving the concept more or less because like this kind of stuff is a long-term concept. So when we are testing it on a monthly basis, yes, I don't know. Christmas sale, I have no idea. Black Friday and everything is gone. Like there's too much variability on a monthly basis. What else? Wow. What is your second best idea? What is your third best idea? Huh? Quarters is same as monthly. What about this one? There are 180 countries in the world. So we could use a cross section instead of like only one country, and then we have much more observations. So that's also an idea. So what will follow, like in your exercise class, is that we will not run this kind of regression on a decade basis, but on a yearly basis. And then we switch to the euro area where we also have some observation. And then it is the case that we have a second a data set for the euro area where we not only have like the uh, inflation rate and the growth rate in money supply, but we also have the growth rate of GDP. Because we were talking so much about quantity equation, and in the quantity equation we have money supply, we have the prices, and we have GDP growth rate. Until now, we assumed growth rate of GDP is constant, but it doesn't have to be the case. There is some variability, and hence we can use one regression with two explanatory variables. And this will be like the next step. Great. Then, like, thank you so much for today. I'll stop recording and I'll